Okay, so we're starting today by looking at the 2001 AP short answer problem. 2001 AP short answer. And those of you who are watching by video, that document is, I'm going to put it up there available to download. Honestly, it's actually not there right now, but I do want to discuss it with you. It does say on that document that a radio station is conducting a contest and people are given coupons, and if the coupon number is 1 to 5 and their coupon is selected, they get a $200 prize, and coupons 6 through what get a $100 prize? Because 6 through 20. If someone gets like coupon 19 and get a little bit higher so you can see at home. If your coupon is 6 through 20, so if you get coupon 19, and if you're randomly selected, you get a $100 prize. 21 through 50 are the other coupon numbers, and if one of those is selected, they get a $50 prize. Now, what is the limit that all of the winners is going to have to be for this contest? The radio station is not willing to give out more than what for all the winners combined? $300. So once it hits $300, they're done. So what they're supposed to do is go through this random digit table, and the random digit table starts out with 7, 2. You see this on the document. The first quintuplet is 7, 2, 7, 4, 9, 1, 3, 3, 4, 7. So what are the outcomes here? Let's see. The 72 is ignored because what we'd have to do is say, no, we'll ignore 51 through 100, 51 through 99. We're also going to have to ignore 0, 0. So that's part of the scheme, is ignore 51 through 99 and 0, 0. So 74, ignore. 91, ignore. 72, 74, 91. But we actually do get a 33. So coupon 33, what happens? They get $50. What's the next award that's given out? Coupon 47 is selected. They get $50. So we're up to a total of 100, so the contest keeps going. Can someone tell me what the next winners, the coupon number of the next winner is according to this random digit table? Yeah, because we go 65, 03. Okay, 3 is winner. Wow, how much does that winner get? 200. 200, so then we stop. And see, if it had gone 50, 50, and then 50 again, and then 200, we would have had to skip that $200 winner because we cut it off at $300. So that would be kind of unfortunate.
But then the same first meets or exceeds 300?
I'm sorry, it says what?
First meets or exceeds 300?
Can exceed. Well, if it's at like 250.
Yeah. Yeah. Oh, okay, numbers continue to be drawn without replacement until the total amount awarded. Oh yeah, first equals or exceeds. Yeah, first equals or. Okay, so you're right, Val. It wouldn't stop. We wouldn't skip this $200 winner if there had been $150 previous. So it's 300 or more. So the first time it exceeds or meets, exceeds or equals $300. You're right. That is the stopping rule. So, but in this case, the number of winners was 3. Now, I want to let you know where they go on the AP test with simulation problems. This is one possibility. They may ask you to use a random digit table to find out how many winners there are. They might actually give you the results. So I'd like you to look up here at some possibilities here. What is the minimum number of winners you could ever have according to this contest?
2.
Yeah, you'd have to have at least 2 winners. What is the maximum number of winners you could ever have?
6.
Yeah, if you had 6 $50 winners, is there any way to get more than 6? Suppose you have 5 $50 winners and then a 200. Yeah, Yeah, the total amount of money that they hand out, that has a distribution, but if W represents the number of winners, it's gonna be either 2, 3, 4, 5, or 6. And suppose that you run a simulation, and this time we got 3 winners. So oftentimes what you'll see on the AP test is they'll set up dot plots that show the results of a simulation. Suppose we run the simulation again, and it was 3 winners, and then 4 winners, and then 2 winners, and then 6, 5, 4, 4, 4, 3, 2, 5 winners. And I've seen it on the AP test where they just give you the results of a simulation that had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This simulation had 15 trials. And then it'll be in the multiple choice section, and they'll say, what is the probability that the number of winners based on this simulation that somebody ran, the number of winners is 5 or greater. And then it would be a multiple choice question where you just have to look at the dot plot and figure out what the probability is. Or it could be a histogram where they say, look, there's 2 dots in this bar, 3, 4, 4, and 2. So would you please tell me, based on the simulation that is depicted here in this dot plot / histogram, what's the probability that the number of winners will be 5 or greater? And then tell your shoulder partner what the answer is. So Katie, what did you get for your answer?
I said 6 out of 15.
Okay, 6 out of 15 is an answer being recommended here. Raise your hand if you agree that the probability, according to this simulation, the probability that there'll be 5 or greater winners is 6 out of 15. Okay, it turns out the answer is 6 out of 15, which is identical to the answer that you gave, Katie. Congratulations. Yeah, that's it. But that's how they can check to see if you understand simulations really fast in a multiple choice setting, is they'll give you the results of the simulation and ask you to basically find the area under a curve. It's like finding the area under a normal curve, except instead of using normal CDF, you're just using a histogram and adding up the numbers in each bar of a histogram. Yeah, question?
Can we simplify the answer?
Yeah, I mean, if it's multiple choice, they might have it as 6/15, they might have it as 2/5, they might have it as 40%.
So it's still the same meaning, right?
And they all have the same meaning, that's correct. Now, one thing that I've already told you, but I wanted to include on the video, so I'll make this fast because people in the room have already heard this, but people on the video need to know that on the homework that was due today, if your simulation came out to be greater than 5%, instead of using the phrase, accept the null hypothesis, in statistics, we use the phrase, failed to reject the null hypothesis. So if you're listening at home and you have further questions on a real world example that might illustrate that, feel free to approach me. But if your probability that 3 varsity football players win the lottery came out to something greater than 5% according to your simulation, instead of saying accept the null hypothesis, instead say fail to reject the null hypothesis. Okay, now on the handout that you were using for this, I'd like you to turn the page to find out what the answers are. I'm just going to pull that up right here so that you can see what it says on the handout. Okay. This is 2001. Yep, here it is. We're going to do beginning of, we'll do a new flip chart. So this is the problem that you've been working on, and I gave you a paper copy of it. Those of you watching at home, there will be a regular copy or a digital copy listed. Look at what the answer that AP graders were hoping you would write down. They were hoping that you would describe your process like this, and it contains a scheme, a stopping rule, a count, or what is also called, you saw it in the video, a response variable. Like, what are we looking for? The response variable. And non-replacement, which is really a statement about numbers to ignore. Which numbers do we ignore? But recall the wording of the question was, explain how you would conduct a simulation to estimate the distribution of the number of prize winners each week. So we're trying to get a distribution. I think it would have been a better question back in 2001 if they had said to estimate the probability that the number of prize winners will be 5 or greater, or to estimate the probability that the number of prize winners will be 3. If they had said estimate the probability that the number of prize winners will be 3, and if they had only 3 trials, it would have been 100% because 3 out of 3 came out to be 3. And I think if you would have kept going, you would have realized that the first trial had 3 winners. The second trial had 3 winners, 250 and 50. The third trial had 3 winners. So if they had said, use a simulation to estimate the probability that the number of winners will be 3, your answer would have been 100%. I guess it happens every time. Well, it doesn't. What if they had said, find the probability that the, right here, yep. What if this had been the outcome of the simulation? Say, what's the probability that the number of winners is 3? If this were it, then it would have been 3 out of 15. 3 out of 15 times the number of winners will be 3. So it's going to vary from simulation to simulation. But oftentimes what they give you, they'll give you the outcome of a simulation. But it's still interesting to see what did they expect students to do back in the year 2001. This was question 6. This was the very last free response question of 6 questions. And they had to say, obtain a 2-digit random number from the random number table. If it's between 0, 1, and 50, use it to represent the selected ticket. It's like they're attaching, they use the word represent to attach meaning to numbers. They know about spherical chickens over there at College Board. They know about attaching meaning to symbols with words. You had to actually attach meaning to symbols. It didn't have to be 1 through 50. It could have been 51 through 99 and 0, 0. Notice that you had to write down which ones to ignore. Which they ended up saying, again, ignore any tickets. So actually, you usually have to talk about which numbers you ignore only once. This is back in 2001. They're still trying to figure out how to write these tests. These days, they don't ask you to write 2 ignore statements. A stopping rule. If you're writing directions to people who work at a radio station, they need to know how to run the contest. So you're giving them directions. So determine the amount of the prize associated with the chosen ticket. Add this to the total amount awarded so far. If the total award so far is less than 300, repeat the process. If it's 300 or more, stop. So they're telling them when to stop giving out prizes. This is important. We don't want to give away all our money. We're only willing to give out up to, I guess the maximum would be $450 is the maximum we would ever give away, $450. So count. And then the response variable is the total number of winners. Back then they called it count, but these days we call it a response variable. Is the total number of winners. So that's what they wanted. They wanted you to write directions to the radio station employees. And then for part B, they had to actually record what happened in the simulations. And there's only one correct answer for these because everyone had the same random digit table. Everyone across the planet who was taking the AP test that year. And we know how many people were taking the AP test that year because all we have to do is go to the Wikipedia page for AP Stats. AP Stats has its own Wikipedia page, which can pretty quickly be pulled up by using the search terms Wiki, AP, Stats. And it's the first thing that comes up. And you can find out how many people took the test back in 2001. In 2001, the number of students, there were 41,034 students in the galaxy who took the AP Stats test that year. Most of them were on planet Earth. I can assure you of this. The first year they gave it, 1997, was only 7,600. Like, what? I can't believe they don't have 2019, because they have the distribution of fives for the year 2019. 15% got a 5. Yeah, but anyway, so now it looks like it's over 200,000. Looks like over 200,000 students, galaxy-wide, take the AP Stats exam. Well, that was fun. Okay, so back to what they did back in 2001. So they have the scoring. Here's what you have to do to get an E, or a P, or an I. They said there's 5 components, and then here's how you get an E, P or I. Did they not have E's, P's, and I's back in 2001? It looks like one correct. Yeah, on this one, I've never seen an AP problem before where they didn't use E's, P's, and I's, but I guess they didn't at that time. Okay, so now you get to practice this. On the handout that I gave you, you had a World Series problem. And on your World Series problem, which I think looks like, I think this is the right document. I would like you to attempt to write a scheme, a stopping rule, a response variable, and I think that's really all you need, because the non-replacement rule is really wrapped up in the scheme. So would you please look at problem 36, the World Series problem. The World Series ends when a team wins 4 games, and suppose that sports analysts consider one team as a little bit stronger with a 60% chance to win. Okay, for any given game, any individual game, 60% chance to win. Estimate the likelihood that the underdog wins the series. I provided you with a random digit table. So page 3 of your notes has a random digit table. I would like you to write a scheme for modeling this situation, because you want to estimate the likelihood that the underdog wins the series. So this is best of 7 games. It could be the underdog wins first game, second game, third game, it could be a 4-game series. But it could go win, underdog, strong. Let's use S for the strong team and W for the weak team. We don't want to use okay, let's use S for strong, W for weak. So see if you can do it. See if you can write a scheme. I'm going to pause the camera. You try on your own to write a scheme and a stopping rule and a response variable. Just a quick note, the World Series is going on right now. I think game 2 of the World Series, does anyone happen to know what teams are in the World Series this year? The Nationals and the Astros. I saw a news story that game 2 had the lowest TV ratings of any World Series game 2 in the history of mankind. So it looks as though for televised World Series, that the World Series has never been as unpopular as it is right now. We're living, and I'm amazed that any of you actually know who's in the World Series. This is, wow, this is something. So I'm just gonna pause. I'm gonna ask my students a few questions and we'll come back. Okay, so we've been struggling through with how to do this. I do want you to be aware that the textbook did generate some answers on this. And I think I have them. And it looks like I had them on the other document. There was a typo in it. That's why I'm working so hard to bring this up, because we should get rid of the typo that was generated in the answers that are online. And I thought I had them right here, so I'm just gonna have to re-download this PDF. But it's the 4.8 random digits master. I think this will pull it in. Let's go at the end of the current flip chart. And I think this is it. Yep, sure enough. So I'm going to delete the pages that I already have, which are this page and that page and this page. So notice the typo in the official solutions that came from the publishers of our textbook. They said, the answers will vary, component is one multiple choice question. So they're using the language of component. That's something, yeah, one possible way to do this is, that's lucky guessing. So now we're down here, answers, they did 1 through 55 is a win by the favorite team. That should have been 01 through 60, so change that on your paper. They used 55, should have been 60. And 56 through, so that would be 61 through 99, and 00 represent a win by the underdog. The trial consists of generating pairs until one team has 4 simulated wins. The response variable is whether or not the underdog wins. So a simulated percentage of the World Series. So it tells you how to calculate, just like we did on the homework that was due today. Just calculate the total number of successes by the total number of trials. And so if we use that, I'm not sure if they have the same random digit table that we did, but just to give you an example of how this unfolds, what you should have been doing was going 11, so that's the strong team wins, 16, strong team wins, 43, strong, 63, that's the weak team, 18, strong, oh, that's it, 4 games, so we have a win by the strong team. Strong team wins. Okay, then another World Series, 75, that's the weak team, 06 is strong, 13 is strong, 76 is weak, 74 is the weak team. We still don't have 4. We have, oh, the weak team is winning 3-2. Oh, the strong team, now it's going to the 6th game. It's going to the 7th game. Oh, the strong team wins in game 7. The response variable could be which team wins. The response variable could be how many games were in the World Series. Was it a 4-game series, 5, 6, or 7? There's all sorts of different response variables you could have had. So, but here it's strong team wins again. And you keep on going, maybe do it 10 times. And then say, out of 10, or maybe you could do it 100 times. Out of 100 World Series, what percentage of the time did the weak team win, the strong team win? So that's how they're moving through that. We're just giving you more experience with how the AP test deals with simulations. It's very unlikely that you would have to spend a lot of time on this. You're certainly not pressing enter for half an hour on the AP test. That's just for concept development that you did for homework, that you would never have to spend that much time on a simulation problem on the AP test. So I want to let you know what the homework is due 1 week from today. I'm giving you the paper handout. Those of you who are at home, make sure you get this paper handout from me. And take one hand back. Katie, your question.
When you have like the random digit table, would you ever only take 1 digit, or would you?
Yeah, there could be situations where you only need 1 digit. In fact, if you look at the problem on page 1 of today's handout, only 1 digit is required. You can look at the problem and the solution that's included in your notes. So yeah, it's not always going to be 2 digits, sometimes 1. Okay, so this problem that I just handed out is due 1 week from today, and it's based on sampling. I just want to read the problem for you because it'll tell you what to pay attention to next week when you come to class. The National Hockey League has 30 teams. Each team has 23 players on their active roster. The teams are divided into 2 conferences. Eastern, which has 16 teams, Western has only 14 teams. That's not like the National Football League. What are they thinking? Each conference is divided into 2 divisions. So Metropolitan and Atlantic Division for the Eastern Conference, Central and Pacific for the Western. Each conference, suppose the National Hockey League wants to conduct random drug testing of its players. Now they're doing random drug testing. Oops. A, describe the process to take a simple random sample of 100 players. B, a stratified sample. C, a cluster sample. Next week in class, you're going to learn how to do drug testing using random samples, simple random samples, stratified samples, and cluster sample. You don't know this yet, so you can't start the homework. It's due 1 week from today. Come next week to learn about sampling for drug testing. You are dismissed.